the AllThingsXR podcast. Where you can get the best AR/VR analyzers from the biggest names in the field. Hi everyone, welcome to the AllThingsXR podcast. I'm Mojtaba. In today's episode, we have a conversation with Noah Zerkin from CombineReality. Hi Noah.
Hi, how are you, Mojtaba? Thanks for having me on.
Sure. Welcome to the AllThingsXR podcast. Noah, can you tell us more about yourself and your company, CombineReality?
Okay, so CombineReality, which I founded, somewhat co-founded, is a brand under which I'm developing and launching a line of Project North Star based augmented reality headsets called the Deck. Although now that Valve has released their Steam Deck, I might want to reconsider that, since that product may find its way into the space. So CombineReality is a brand that was created for the commercialization of Project North Star headsets, and I'm a very long time wearable computing and augmented reality enthusiast and sort of tinkerer, maker, hardware hacker, to the extent that I've done, XR software development. It's a little bit limited, but so my main focus is hardware, and I was first inspired to get into this a very long time ago with a visit to the MIT Media Lab when I was 14. So, and I can go into that in more detail if you want later. But yeah, so I'm sort of a hardware hacker and product developer currently based in Shenzhen, China, but originally from New York City.
Mm-hmm. Great. So now, one of the projects you mentioned was Project North Star, which I believe that got pretty popular. Can you tell us more about it and tell us what was the initial idea and how did you build such a device? Was that a one-man show or you worked on it in a team?
So I'm actually not the original instigator or creator of the project, of Project North Star. Project North Star was born at Leap Motion, actually. Now Ultraleap. You're probably familiar with their hand tracking devices.
Yeah.
With their hand tracking technology. They're still the gold standard for that, although Facebook's catching up. So actually, the way North Star came to be is that a young guy by the name of Adam Munich met David Holtz, the founder of Leap Motion, at a party at a hackerspace in the Bay Area, and basically approached him and said, "Hey, I've been working on this idea for an augmented reality headset, and I think that between what I've done and your hand tracking technology, we could build it. We could make it a reality." Now this was actually 4 or 5 years ago, and when they first revealed Project North Star, it was right around the same time that pricing and specifications had been announced for the Magic Leap 1. Now, as a longtime AR aficionado and somebody who had built AR hardware in the past, I was very intrigued by this Leap Motion reference design that they said they were going to release. Actually, one of Adam's conditions for joining Leap Motion to develop this headset was that they open source it.
Uh-huh.
And so when the project was announced, it was announced as an open source project. And it was then quite a while before they actually released it. And it sort of coincided with the actual release of the Magic Leap 1, when people were actually getting their hands on it and were somewhat disillusioned with it. So now, one of the most intriguing things about Project Northstar was that Leap Motion asserted that it could be built for about $100.
Uh-huh.
Now, they were talking about at high volume and without certain subsystems in there, right? So now a lot of people, however, saw that and thought, well, I'm going to try to build a $100 Project Northstar headset with a 100-degree field of view and so forth. So I was one of those people. So it was now another compelling part of this was that the mechanical portions, most of the mechanical portions of this headset, could be 3D printed. Now 3D printing is another thing that I'm pretty passionate about, and so I decided to build one of these one-off headsets for myself.
Mm-hmm. And
now the Project Northstar headsets, that original reference design it's come a long way since then. But the main constraint for building this headset was, as you might imagine, the optics. Now, these are fairly simple birdbath combiners, but not nothing so exotic as waveguides, but still rather difficult for an individual maker to produce. And that, of course, if you're making a one-off, has a very large impact on that hypothetical $100 price tag.
Mm-hmm.
So sorry, I'm rambling on a bit about this, but this is sort of how I got involved. How I got involved in this. So it started out as my wanting to simply build an instance of somebody else's reference design, and after exploring what the actual cost of producing these combiners was going to be, right? Having them to produce them up to Leap Motion's specification was going to require having these diamond turned out of a block of PMMA, so milled out, polished, to optical grade, and then coated with a series of coatings that are sort of beyond the reach of your average amateur. So and part of that, so you would think that a simple half mirror coating on the inner surface of these concave combiners, right? These birdbath combiners, would be enough, right?
I see.
Except that, are you familiar with secondary reflection?
Yeah.
Exactly. So the issue.
But please explain it for our audience.
Okay. So the light passing, reflecting off of, you've got half of the light reflecting off of that primary reflective surface that's closest to your eye. And the other half is then traveling through through the combiner, through the lens, if you will. Although it isn't a lens per se, but and you would think that would be it, except that there's the outer surface of the combiner, and so what you end up with is a reflection off of. I'm trying to think of a way to, I'm trying to put it into the simplest terms.
Yeah.
Obviously. So transitions from one material to another. In this case, the material of the combiner. The most recent ones made of polycarbonate, previous ones PMMA, cause light to bounce, and it's like the principle of total internal reflection. You end up with some of that light bouncing back from the surface inside the combiner, that outer surface, and that ends up causing a ghosting effect, an offset secondary reflection, which especially because of the angle of our optics, is different for each eye and different across the field of view. So it's really disruptive to the experience. And so that means you need an anti-reflective coating, or microstructure, nanostructure. You could do this with a texture in the injection mold, but the easiest way, and it's still not easy, is with an anti-reflective coating stack on the outer surface of the combiner. So finding a good broadband anti-reflective coating that basically gets rid of all of that light, whether it's by scattering it, absorbing it, or otherwise keeping it from reflecting back to you as a second coherent reflection. It's not the easiest thing to source or to formulate. So that was beyond the reach of most of the people trying to build one-offs.
I see.
And then there was the milling. So having looked into what the cost of producing a single set of these combiners for myself was going to be, I was already situated here in Shenzhen for other reasons, and I can tell you the backstory of that in a bit if you'd like. I figured that, since I was here in Shenzhen with mass production capabilities close at hand, inexpensive mass production capabilities close at hand, rather than spending, somewhere in the neighborhood of $1,000 to get a single set of combiners made, I would just have an injection mold opened and mass produce them for everybody who wanted to build their own Project North Star headsets. So this started out as an effort just to enable like-minded builders of this headset reference design initiated by Leap Motion. And so, and the injection mold to do this was going to cost about twice what a Magic Leap 1 was going to cost. Ooh. And I figured would have a much greater return for the community, and in terms of the number of AR headsets that would be on people's heads, right? I could buy one or two Magic Leap 1s and develop against that, anticipating that would be a fairly limited audience and within the limitations of that device, or I could enable thousands of people to build their own Project Northstar headsets for about the same amount of money. So that's where I put my cash, was in opening injection molding tooling and mass producing these combiners, which were sort of the hardest thing to get. Also being situated in Shenzhen, it was much easier to form relationships with vendors for the other parts in this headset reference design.
Exactly.
So, for instance, BOE, who makes the displays that we use in the headset. And these are actually the same displays that are in the Valve Index. So, two 1440 by 1600, very low persistence, 120 hertz, LCD displays that are really made specific. They're 3.5 inch. So they're made specifically for XR. Although originally VR, right? Mm-hmm. So one tends to think of AR, purpose-built AR displays as micro displays, because you want to fit them into, a small unobtrusive pair of glasses, that look like a pair of Oakleys, or in the case of Vuzix, or some other compact form factor, and which Project Northstar absolutely is not. It is this big, awkward-looking thing, but produces a better experience than anything else you can get in a similar price range, certainly. So, that. Let's see. How did I go off on that tangent? I'm sorry. So getting those combiners made and enabling other people to produce it was sort of my primary goal. Right, established a relationship with BOE, so that I could source those displays, and that was actually really a matter of that there was a trade show happening at the convention center across the street from my office, and maybe 2 days after I had decided that I was going to source a few hundred of these displays to get started with. So I walked across the street to this convention center, found the BOE booth at the conference, got somebody's card, had them put me in touch with the right people, and then had them come visit our office and see the samples of the combiners that had made, that we'd had made, so they'd take the project seriously, and then they said, yeah, sure, we'll sell you displays. And then so basically there were a number of hard to source, hard to produce components for this headset, and I sort of took it upon myself to make those accessible and so that people would have this platform to build on. And then as the supplier of these parts, I benefited in that the market for them and the market for the headsets increased, gradually, but in an accelerating way, making the platform itself more compelling. Just like any open source project, when there's sort of been a critical number of contributions made to it, it becomes much more attractive. And this project, fortunately, has continued to attract more and more people who want to develop for it and build on it, whether it's software or hardware.
Yeah.
So that's sort of how I got involved in the project, and it's sort of grown from there. Ultraleap, after the Leap Motion and Ultra Haptics merger, have continued to be involved and supportive. And the headsets still include their hand tracking technology, which is one of the most attractive technologies in the headset. And so, and right now we're and we've been working on this for a while, and there have been frustrating delays that I can also go into why there have been delays, but we're working towards an injection molded, mass produced headset with a mature SDK and a really mature set of sensors and features that will really let it hold its own against and alongside anything else out there.
Great. So now, what's the underlying software system? Is it relying on AR Core and AR Kit, or is it something else?
So the beauty of Project North Star is that it is basically completely platform agnostic. So it's a tethered headset, like like an Index or a PC VR headset, and has all of the sensors necessary, but it isn't really locked into anything proprietary. It's an open set of subsystems that work together. So right now, you can develop for it on Windows, and that's probably where it's most mature. But also on Linux. Those are the two main platforms for which people are developing software for Project North Star headsets. I would love at some point to incorporate an XR2 or even whatever its successor is, or to be able to tether it to an Android device as the brains of this thing. But for the time being, it's a tethered headset, and the development process looks a lot like the VR development process on those two operating systems. So, on Linux, we have an OpenXR runtime in the form of Calabra's Monado, and people have incorporated support into StereoKit, which is a great sort of interaction and hand tracking framework for OpenXR. And then on Windows, we've been mainly focused on Unity. So the original software release for Project North Star from Leap Motion was a Unity asset package that contained most of the necessary optical distortion code and the hand tracking, right? And then to that you could add basically any 6 degree of freedom solution that you wanted, whether it was Steam VR, right? Lighthouse tracking system. You could put a Vive puck on top of this thing, and that works just fine. You could put retroreflective markers, a retroreflective rigid body on it, and use a high-end, Vicon motion capture system if you wanted to. Or you could take the approach that I did and use an inside-out tracking system, onboard SLAM. And so actually the first sensor that I incorporated into a Project North Star build was for inside-out tracking was the structure core from Occipital. Yep. So I've at the time Jeff Powers and Vikas Reddy were still the senior guys at the company. They've since left to and are doing different things. But
we had Jeff in a recent episode.
Ah, great, perfect. So Jeff and a bunch of the folks from Occipital left to start Arcturus Industries, and sort of continue the SLAM research from Occipital. But the first sensor that I put on there for doing inside-out tracking and was also hopefully going to get environment meshing out of it, but sort of never did. Was the structure core and using their perception engine integration. Unfortunately, that never really fully matured while at Occipital, just because the company had different priorities.
Yeah.
Then after that, switched to so I've used a number of different solutions, all of which are still supported, but right now most people are using the Intel T261, which is the module form of the T265, which is a dedicated SLAM module. I don't know if you're familiar with IMUs like the MPU 6050 or the 055 or 080. The T261, so the reason I mentioned those two IMUs in particular is because they do all of the sensor fusion on board and spit out, fully formed orientation solutions. They spit out quaternions, which takes a lot of the math overhead, one off of the host, but also relieves developers of the responsibility for doing that sensor fusion themselves, which is a complex bit of math. So the T261 is the sort of the SLAM equivalent of that. It has two stereo fisheye cameras and an IMU, and then an Intel Myriad. I believe that one had the Myriad 2. Neural net processor on board. On board this little module, and it gives you. In the same way that those IMUs spit out quaternions, this one gives you an orientation and translation solution. So you have your full 6 degree of freedom solution without even needing to get the camera feeds or the IMU data. They are accessible, but you don't need them. So again, that takes a lot of overhead off of the host and just makes it an easy drop-in solution for us.
So, no, you had good experience with those because I've also experimented with Intel RealSense T-Series, but the drift issues are somehow irritating in relatively large spaces.
Yeah. So in relatively larger spaces, they are annoying. Also, the jumping. So the T261 has an integrated relocalization function that will, and it's sort of an anti-kidnapping measure, if you will. So if it has, if the confidence of what it ends up resulting in is sort of a multiple fragmented maps, internal representations on the device, and if there is a better match in one map than the other, or if the device thinks there is, it will jump to that other sort of completely separate map, and you end up with these multiple coordinate systems, and the device jumps back and forth between them. You can disable this. It is not well documented. You can suppress that behavior. You can also preload a map and disable relocalization and the jumping. At that point, there is still an issue of drift, but the experience doesn't break where suddenly, with that relocalization, everything in the scene might, suddenly jump half a meter to the left, and it obviously breaks the entire, breaks the immersiveness of the experience. So we don't consider the T261 a long-term solution. We want to get away from it as quickly as possible. And one of the sets of hardware that we're looking at is the Luxonis Depth AI platform, the underlying platform for the Oak D that was and the Oak One that were recently funded on Kickstarter as a collaboration with OpenCV. Right?
Yeah.
Yep. So we're actually working pretty closely with them, and we're advocating for some SLAM-centric features on the device, and it now has a pretty robust feature tracking module in there, so we're gradually seeing that the necessary set of features being built out. It isn't quite there yet, so most people are, for the moment, still using the T261. Other people have used the Z. The XVisio sensor modules are great. So and again, this is why sort of being a platform agnostic collection of parts and keeping this thing modular is so critical. It is, it's a development platform, both for hardware and software, right? And so we're seeing it gradually get more robust, and as more suitable sensor modules emerge, we can swap out what we have. And part of what I like about that is that because this is still an evolving field, both from a hardware and software perspective, with rapid progress being made on all fronts, just because you've sort of committed the money and effort to get involved in this and invested in a headset, doesn't mean that investment will be wasted when a better technology comes out. You can simply swap out that module and keep using the rest of the hardware.
That's great. So, Noah, how do you think open source hardware projects will affect the hardware market in the future? Will they have the same effect as open source software?
I would say that in certain areas they already have. The most obvious of which would be 3D printing, of course.
Yeah.
And that's actually a big inspiration for how I've approached this project. I was lucky enough, and this ends up, this is actually a critical part of my own backstory. I was lucky enough to witness the MakerBot team form in New York, and sort of closely watch their progress and talk to both Bree Pettis and Zach Smith at length about the open hardware model and what the pros and cons were, and so forth. And so we would not have, $300, high quality desktop 3D printing that allows people to prototype their ideas, if not for the fact that this was an open source technology.
Yeah.
And so so I would say right there that's already a very high impact, effect of open source hardware. And then there's the Arduino, right?
Yeah.
The Arduino has been incredibly high impact, including including in the 3D printer market, but even on the North Star headset, right? The firmware running on the display driver board is based on an Arduino bootloader. The firmware on the on the internal hub system in the headset is also Arduino based, right? And the reasons being that not that we couldn't write a lower level implementation of these functions, it's to make it easy for other people to make changes and contribute to it, right? Yeah. So and I actually ended up getting into hardware because of Arduino. I think for most, you won't find too many people of my age, and I'm 40, so I don't think you'll find too many 40-year-olds who will say that they, who have ended up doing professional product development, who would say that they got into doing electrical engineering because of the Arduino. But I was a bit of a latecomer to this field. Or at least the professional practice of it. And so, and the Arduino made it very easy to get into it quickly,
exactly.
realize some of my ideas in a very satisfying way, get that sort of positive feedback loop going, and positive reinforcement, right, of thinking, hey, I want to build this thing.
Yeah.
And, a few days later or a week later having it is incredibly gratifying and makes you want to dive deeper into it. So, I think we have, we've witnessed a huge expansion of the embedded development field and invention, independent invention, by virtue of the fact that there's this highly abstracted, highly accessible embedded development platform, and then that the hardware itself is open source, and you can build production hardware based on it if you want, and variations on it. So. I would say we've already seen it, even though some people might not be fully aware of it.
Yeah, I see. Now, can you also tell us more about your recent project, the other Project Tact? Can you tell us more about that?
Okay, so Tact actually isn't that recent, amusingly.
Really? Yeah, I hadn't heard of it. Yeah.
Well, because I never commercialized it, and I may yet. Tact is arguably, had I commercialized it, it was basically the first 3DOF VR controller, at least in terms of the combination of functions that are on there. But that wasn't its original intent. And this is the thing that actually originally brought me here to China, which is something I can segue into in a minute. But it's funny, all of this ties together pretty tightly. So immediately after building my first Arduino project back in the late aughts, so 2008, 2009, which came about because my neighbor was an industrial design student at Pratt Institute in Brooklyn and wanted help on his thesis project, and said, "Hey, Noah, you know how to code a bit. Do you I'm building this thing. I have no idea how to write the firmware. Could you help me?" And so I did. I asked him where he got this incredible Arduino thing. He pointed me towards SparkFun, and I went and checked out the site and said, "Whoa, there are MEMS gyroscopes and accelerometers and all of, I could build a motion capture suit out of this stuff." And this was, around, I guess, 2006, 2007. And so I decided to build a homebrew mocap suit. And that ended up becoming a sort of hand-worn partial glove through a series of iterations. And so I developed a certain level of expertise building these homebrew prototype input systems for spatial simulations and spatial interfaces. Tact was an offshoot of that eventually because of Google Glass. So I got one of the early Google Glass Explorer units, and it turned out that I could not stand the swiping on the side of my head interface modality. I absolutely hate it. And so I, started building an input device for controlling it. And I then applied to Haxcelerator, now known as Hax. Are you familiar with Hax?
No.
So Hax is a hardware startup accelerator based here in Shenzhen, funded by SOS Ventures, Sean O'Sullivan, and they have offices in the Bay Area as well. But the main accelerator is here in Shenzhen, and the resident. So it was originally based out of Seed Studio, which is an open hardware company, and the resident engineer there was Zach Smith, Hogan, who was the founder of MakerBot, and who had just left the company over the fact that it was turning in a closed source direction. I was looking for ways to commercialize, to fully develop and commercialize this input device for controlling Google Glass and other monocular heads-up display systems. So that's actually what I came here to do. And I like to tell people when I sort of see them developing monocular heads-up displays that follow Google Glass's cue and have that little trackpad on the side, that I hate that interface modality so much that I moved to China to eradicate it. So what the device actually is a tiny, maybe 3.5, maybe 4 centimeter on a side. I don't have one in front of me, and I probably ought to know that off the top of my head. Trackpad, clip-on trackpad with an IMU in it, and running tilt-compensated air mouse firmware. So it's a combination trackpad and air mouse that interfaces over BLE and can is very versatile, can be used for controlling, not just monocular heads-up displays, but other, really anything. It's sort of a multi-purpose, multi-purpose device. The original intent being that it could clip to a belt or a pocket or a wristband or the strap of a bag. That the trackpad, the multi-touch interface on it, could be used to control a heads-up display or other devices, using little swipes on the surface, but that it could also be unclipped and used as a more spatial interface device as well. It also has it's also force sensitive, so it sort of has the equivalent of force touch on Apple products and a linear resonant motor, similar to the Taptic engine. So there is a really nice sort of tactile haptic element to it, hence tact. It's also sort of less weird than reaching up and swiping on the side of your head, hence tact. So the name works on a couple of levels. The reason why I never finished it and brought it to market was that Google Glass broke third-party or any external input device support. So I was here developing the product. The Android Bluetooth stack on the Google Glass originally did not support HID over GAT. So that's basically mouse and keyboard over Bluetooth low energy. It only supported Bluetooth Classic, so Bluetooth 2 input devices, and even then only after a hack, which they showed people in a Google I/O session. So I actually spoke to people there who said, don't worry, you're on the right track. We're absolutely going to enable BLE input devices, and so to keep doing what you're doing. You're absolutely on the right track. It took a very long time for them to finally upgrade the Android kernel version on Glass, and it finally supported BLE. However, at the same time, they completely broke or blocked input device support altogether, not just BLE, but Bluetooth Classic. So it went from, at the original pitches and sort of demo day talks that I gave with WarePoint Tact, because it was a BLE device and Glass didn't support that, I'd actually built a little intermediary device, little bridge device that I had hidden in my pocket, and so the Tact demo unit was connected to that via BLE, and then it was relaying HID commands via Bluetooth Classic, and after this update, I couldn't even give those demos. So it sort of negated the entire, the reason for this device's existence, at least for a while. Now, now smart glasses are coming back, and and they're and in fact, this was infuriating. Maybe 2.5 years ago, I picked up my my Google Glass and put it on, just for the hell of it, just for fun, and went and looked at the preferences. They had pushed out an update maybe a month before. It was the first, and it that coincided with the Google Glass Enterprise Edition 2. They had pushed out this update, and it was the first update in 4 years or something. I go and I swipe to the pairing preferences, and there's a function there, and a menu item, pair BLE input device. And my jaw just dropped. Just like, are you serious? So the hardware supported it all along, as I knew, but so there finally, the device that I'd built for it, 4 or 5 years earlier, finally worked. So I then started that project back up, and sort of just as I was finishing it up, and that there were just a few little things left to do on the firmware, and one fix to make to the power management system on it, but overall the hardware was done. Northstar came along, and I sort of dove right into that, and I might start WearPoint back up again sooner or later, but it's not my top priority at the moment.
Yeah, I see. No, have you also experimented with UWBs?
So I haven't, but there are people in the Northstar community who are very bullish, very enthusiastic about this technology. I tend not to focus on anything that involves external infrastructure, although there is also the possibility of device-to-device mesh networking, right?
Exactly.
Ad hoc mesh networks, and if enough of these devices are independently location aware and are contributing to the location awareness of this mesh network and the relative positions of the devices within it. And parts of that can be fixed infrastructure, right? If ultra wideband infrastructure with a known location does, gain some ubiquity, then that really does make this a viable option for location awareness, for context awareness, for headsets and
Exactly.
devices. Yeah.
Exactly.
So I have not been. I personally have not been experimenting with it yet. Brian Brown, who is our who has been the community manager on the Project Northstar Discord server, is very enthusiastic about ultra wideband technologies. So, and it's something that we've looked at. I've had other things on my plate for the time being, but given the modularity of the system, adding it would not be a big deal.
Yeah, I think if UWB mesh networks can solve the localization challenge, which is the most sophisticated AR cloud problem, that would just change the game entirely. Facebook, Snap, etc. are putting large sums of money on it, and this will just change the game. And I think the winner will be Apple, actually, with lots of UWB sensors in its devices.
It would be huge. It's potentially a very, very disruptive technology in the best way, the best sense of the word. It's an enabling technology, and I hope things do get built out that way. It would be great to see that adopted. And it's actually, I was looking for a long time at how one could do sort of coarse localization with RFID tags, right?
Yeah.
And this is sort of a the logical evolution of that.
Exactly.
It's not something that I've looked at much lately, but it's nice that there is now an evolution of that technology such that small, inexpensive RF beacons can allow you to triangulate a centimeter scale position.
Mm-hmm. Exactly. So, Noah, the projects you work on are somehow competing with giants like Microsoft HoloLens or Magic Leap and so on. What is your strategy to avoid being disrupted by these big companies?
Well, one is to position ourselves as an inexpensive development platform for prototyping experiences on
Uh-huh.
those, for those more expensive devices, at least until we have sort of feature parity with them. And there are still some things that we need to incorporate. We're still working on our eye tracking system. We don't have a great environment reconstruction solution at the moment. Although we are very actively exploring different options. So for the time being, positioning it as and we've got a really good MRTK integration for the headset, right? So that it makes it really easy to port, to sort of develop for platforms like HoloLens and a Project North Star headset, a DEC headset, simultaneously. And we've spoken to some companies that have developed very successful, XR applications, stuff you'd probably use, that who are have even entertained the possibility and are now in the process of porting their software to North Star because it's relatively trivial, having already written their software on top of MRTK. The other thing is that this does have, by virtue of Ultraleap's hand tracking, it has better hand tracking than you've got on any of the other AR headsets.
Exactly.
And a larger field of view. I avoid saying wider because I would say the most distinctive part of, sort of feature of this headset's optics is the vertical field of view. And people don't really appreciate how critical that is until they experience it. And having a large vertical field of view is almost even more important to natural interaction than the horizontal field of view is. So believe it or not. So that is sort of unique to us at the moment, at least among optical see-through AR headsets. Now, viable video pass-through headsets weren't really a thing when I got involved in this. And so devices like the Lynx headset coming right up, very intriguing. I'll want one. It's a very interesting looking device. I still, sort of prefer the idea of actual photons that have bounced off of the actual objects that I'm seeing, being the photons that are hitting my retina. So I sort of have a visceral preference for, for optical see-through. But video pass-through is interesting.
Yeah.
Also the fact that despite the vergence accommodation conflict inherent to, non-light field display solutions, optic solutions, your eyes are basically fixed at a single focal plane all the time in a video pass-through headset, right? It's and so while it's less of a challenge for the actual experience, it isn't great for your eyes.
Yeah, it's unnatural
So
somehow. Yeah.
it is. It is. Your eyes are remaining. The optical accommodation is remaining fixed while your eyes are converging on not just the virtual content but everything. Um, and and I don't really like that idea. um, so. Um, So I think there are some really compelling reasons why optical see-through, um, despite the fact that video pass-through is more interesting for some things, right? Being able to actually modify the perception, modify the contents of the real world, right?
Mm-hmm.
Being able to fully overwrite things with you know uh, fully masked reality. Having an alpha channel to work
Yeah.
with. Um, uh, those are sort of the that's the most compelling reason to use video pass through. But I think there are some really compelling reasons to keep pursuing optical see through as well. Um, so. So I think it has a sort of unique market positioning, right? It has its advantages over the other stuff that's out there, but I think it is also because of the cost. So I've been selling, hand built, hand calibrated, mostly 3D printed headsets for, depending on the hardware that's on board, between 500 and 800 bucks. That price can be brought considerably lower in mass production,
Yeah.
but remember that doesn't include compute, right? It's a tethered headset. The So if you have a studio full of developers, or even remotely located developers who are working on your HoloLens experience, for instance, right? You can either buy each of them a $3,500 HoloLens 2,
Yeah.
or and which is a pretty large capital investment,
Exactly.
and for every one of your developers, or have them writing code that they can't really test at their desk, and then if it's a co-located studio, and then they have one or two units that they can go test on, or you can have a North Star headset at every single person's desk for a lot less money.
Uh-huh.
And so I see that as a really good potential market for this. And the education market, basically anywhere where cost is a consideration, but quality of experience, the requirements for the quality of experience are still very high. And given that this is an open source project, I think we will see sort of an emergent set of applications for it. I think
Exactly.
I can't anticipate all of the ways in which this is going to be used, and which has been problematic for some conversations about partnerships with, for instance, Qualcomm. They want to know precisely what application this headset is intended for, right? And part of that is probably not stepping on the toes of their other partners, and also just having a confidence in the success of the platform, right? This is going to be really good for industrial inspection, or this is going to be really good for for education, or so forth. And I sort of refuse to commit to a sort of specific use case for something that is such an open platform. It really is up to everyone else how they want to use this thing.
I see. Great. So now another topic I wanted to talk about with you is about China ecosystem. As you said, you live in China. What are the differences you see between China and Silicon Valley tech in a startup ecosystem?
Okay. So I have some degree of experience with both. I can't claim to have been an integral part of either, but also the ecosystem here evolves very quickly, so what I might have to say might not apply to right now, this very moment. In the past, sort of the main critique that I had of the Chinese startup ecosystem was that rather than looking for completely unique investment opportunities, investors were looking for something safe. So you would have one robotics company, for instance, home robotics company, raise a bunch of money and get a high valuation, and then perhaps be acquired, and suddenly home robotics companies were, the thing to invest in. That's what everyone was looking to put their money into. And I was just sort of scratching my head thinking, but that's been done. How are these companies sort of pushing the envelope? What's unique about it? And it was sort of this trend following. Now the last time, sort of the last period of time when I was spending a lot of time in the startup community here was a few years ago. I have sort of had my head under a rock with the North Star stuff. I have not been going out and trying to raise money for this, actually, oddly enough. I've been funding it by selling kits. So which has been great. It's sort of been self-sustaining so far. I'm not sure how much more we can scale without raising some money, but that means that I have not been heavily involved in the startup ecosystem here lately. That said, just in terms of innovative thinking and trying new ideas, I have, I've witnessed more and more of that here, and also just looking at the research papers coming out of domestic institutions here, really interesting XR research coming out of Tsinghua and other well-respected Chinese research institutions. So I can only imagine the the startup ecosystem here becoming more and more innovative. I wish I had more insightful observations about it to give you, but I haven't been heavily involved lately.
No, that was great. No, the face of the internet, I think, is changing. Benedict Evans from A16Z has a great piece on it titled "The End of the American Internet." There's a trend that states and governments try to have more control over the data of their people. China is the frontier in this matter with its Great Firewall. Also, we saw the TikTok ban in the US, and also countries like Iran try to imitate China's Great Wall as well. How do you see this trend of governments trying to have more control will affect the next generation of the AR and VR and the internet, like the metaverses?
So I haven't read the piece. I haven't read Evan's piece. But it's sort of undeniable that there is a trend, at least in a lot of parts of the world, towards that, and which is dismaying as a fan of sort of the Wild West of the internet, right?
Mm-hmm.
As someone who grew up reading all the cyberpunk novels and so forth, Gibson and Stevenson and lots of others. I I sort of love the sort of I romanticize the chaotic, open-ended vision of the internet, right? As a content agnostic, platform, set of infrastructure. So I do find it dismaying that there's more government control over the internet. That said, given the irresponsible behavior of some of the platforms that do deliver their content in an algorithmic way, maybe some degree of regulation and control, curation is necessary. I really hesitate to see that, right? Or to say that, rather. But, I certainly understand the impulse to try to control what's being delivered, and how people are using the internet. Now, you mentioned the attempted, the hypothetical TikTok ban in the US, right?
Yeah.
And which, at least to my knowledge, didn't work, right?
Yeah, exactly.
And that's because it's simply impossible to ban things on I also hesitate to say the real internet. Now, the only reason that the Great Firewall is possible is because China only has 3 IPXs, right? All the traffic going in and out of the country is being funneled through 3, albeit high bandwidth, choke points, right? In Beijing, Shanghai, and in Guangdong, and so that means I think it's a lot easier for them to run deep packet inspection en masse, and it would be a lot harder to actually implement the ban of certain kinds of traffic and software on the quote American internet, on the internet as designed in the rest of the world. It also means that they can, they have these 3 points at which they can implement things like man-in-the-middle attacks and I guess it's not DNS poisoning, but substituting, basically blocking certain DNS queries. So it's almost physically impossible to do the same in the States. And it will be extremely unpopular for me to say it, but I do understand and see the logic of having the Great Firewall sort of reflected here, in that with all of the negative media portrayal and obviously as somebody physically located in China at the moment, there are certain things I can't talk about for my own sake, but the given all of the negative stuff in the media about China, I would say the nationalism here, might be more extreme, and people would be more defensive, more. I don't know if the place would be more insular, but there's they do have reason to sort of try to keep out some of the hostility of the. You know what? I have not thought this well enough to be able to give any sort of authoritative or well-informed opinion about this, but and it may just be that I've been living behind the Great Firewall for long enough that I just sort of accept it. But
yeah.
Obviously, using a VPN to access quote the real internet, but it's. I mean that's a big question. It's a really, it's a really tough question. How it will affect metaverses. Well, you might end up with fragmented ecosystems, right?
Mm-hmm. Yeah.
So separate versions of separate metaverses, as it were. Although I do not, I don't view the quote metaverse as a sort of singular thing. And it has sort of become a loaded term to me. I also shy away from using the term metaverse. To me, the metaverse is a simulation involving something called the street on a black, perfectly spherical virtual planet, out of Snow Crash.
Exactly.
Where Stevenson, coined the phrase. It's sort of it's about as meaningful as the word cyberspace coined by Gibson. Can we talk about the cyberspace? No. It's it's cool that people have adopted that sort of fictional term and applied it to the real world, but and that there's been a lot of hemming and hawing and attempts to define what the metaverse is. Frankly, I see AR as just an extension of the internet and the platforms that we already have. And,
exactly.
Those protocols already exist. Additional protocols will be added, but this isn't. The internet was still the internet when it made the leap from just people's desktop computers to the phones in our pockets, right? Mm-hmm. We didn't change the name of the internet. And people did talk about things like the mobile. Did talk about things like the mobile web and so forth, but nobody actually adopted that. And so, I actually don't see there being a whole lot of longevity to the term metaverse.
I see.
So in terms of, how authoritarian control of portions of the internet, will affect the formation of metaverses, the same way it affects the formation and operation of everything else.
Mm-hmm.
It's infrastructure.
Yeah. So now users' habits are different in different parts of the world because of different cultures and behaviors. Like, for example, QR codes are much more popular in East Asian countries like China and Japan, but not as popular in Europe and the US. But the COVID has changed it a bit, but not that much. How these different habits and behaviors do you think will affect the future of AR and VR?
Well, I could see AR and VR being visually much busier in sort of Asian UI UX, right?
Mm-hmm.
So, the if just looking at the mobile app user interfaces in China versus the U.S., right? In the U.S., we tend to value sort of a clean, sparse design with
Exactly.
sort of hierarchically nested, features, stuff sort of hidden in menus, just to keep things visually clean, and to make it sort of easy to take in everything that's on the display at once. In an app like Taobao, it is incredibly busy visually,
Uh-huh.
and that may have to do with how compact and concise Chinese characters are, right? The
Uh-huh.
writing. So this may just be a function of having written language based on sort of iconography, as opposed to a phonetic spelling out of everything. You can fit a lot more into the same space. So, we might see something like that. See those sorts of differences, between AR user interfaces in the West and in Asia, at least in countries that use these iconographic written languages. The I don't know if you've seen Hyper Reality by Keiichi Matsuda. I'm sure you
I
have.
think yeah I've seen that, yeah cluttered ads and such, yeah.
I think that the likelihood of a reality like that is actually higher here than it would be in the West.
Uh-huh.
Um, uh, just based on observations of existing user interfaces.
Mm-hmm. Mm-hmm, mm-hmm. I see. So now, as of our last question, how do you envision the future of AR and VR?
That is a very, very big question, and it depends on certain things, namely if I think it depends most on whether Zuck manages to push everyone else out of the space or not.
Oh yeah, I agree with
If
that.
if Facebook and their business models wind up being the primary shaping forces for XR, well, frankly, I find that terrifying. Just because XR that is motivated primarily by not by utility, but by holding your attention so as to make observations about you and gain a deeper understanding of you, to even better hold your attention and
Mm-hmm.
sell you stuff,
Yeah.
and manipulate you. um, uh, either because they want to, or at the behest of the highest bidder.
Yeah.
It's that is one dystopia I really don't want to live in. So, um, I hope that is not the future that we see. I do. For me, what I want to get most out of AR is utility, and I
Mm-hmm.
don't know if you could tell just by the nature of my responses to these questions, but I'm pretty ADD. If you're familiar, so a spatial a spatial means that does not require total immersion of organizing and interacting with data, associating thoughts with it, creating structures out of it. So spatial mind mapping that can then be linked into the APIs of both data sources and piped out into systems where they can actually have an effect on the real world. That's sort of my biggest desire for it. Also being able to collaboratively visualize these systems, whether, in engineering disciplines, I think AR will be incredibly valuable, and that's one of the use cases that we see put forward by the makers of all kinds of different AR hardware, right? So visualizing CAD models, being able to rearrange the parts and so forth, and I think that is a very important use case, and one that I can't wait to have. But that we can sort of bring that same idea to more abstract, to visual representations of more abstract data, sort of like node-based programming interfaces and so forth, and for data visualization in general. I think the possibilities are pretty unlimited, though, from, there's obviously some potential for AR gaming and entertainment as well. And that'll be fun.
Yeah.
I sort of see the potential for that. The way I want that in my life might just be sort of as embellishments, sort of entertaining widgets that incorporate with my world as I go about doing what I actually need to. Let's see. There's that ADD kicking in again. With such an open-ended question, there are a lot of different possible answers, and I honestly wouldn't presume to box it into a sort of a single future.
Mm-hmm.
I really think the possibilities are endless.
Exactly. Totally agree. Well, Noah, it was a pleasure. Thanks very much for joining the All Things XR podcast.
Hey, Muchtaba, thank you so much for having me on.